Hello, welcome to OCC Math Seminar video. Today's session is infinite limits and vertical asymptote. So this is the definition of the infinite limits. It's slightly different than the finite limits, right? And I'll explain to you why it is later. Let f be a function is defined at every real number in some open interval contained in C. Then the limit as x approaches C of f of x is equal to the infinity. For each m that positive, by the way, here m is some big arbitrary value, unlike epsilon, which is represents some small value, right? We want it to be opposite than epsilon. We want m to be some big arbitrary value. Then there exists a positive delta such that if the absolute value of x minus c between 0 and delta, then the function f of x is always bigger than some value m. Right, so let me explain it to you here. It's saying that if I have the value m, let's take an arbitrary, really big value m. M could be a million, trillion, gazillion, right? Then there exists a positive delta such that the distance that is the distance x minus c is between 0 and delta, then the function f is always bigger than the value m, the arbitrary m. Right? And again, m is a very big value, right? So that in a sense, this sentence say f of x is greater, the inequality say f of x is greater than m means the function can go to the infinite, right? Similarly, the limit at x approaches c of f of x equal negative infinity. Limit as x approaches c of f of x equal negative infinity. For each negative n, so n here is a very small negative number. I'm talking about negative 1,000, negative trillion, negative gazillion, right? Then there exists a positive delta such that the distance x minus c between 0 and delta, then the function f of x is always less than the negative value n, right? So it, in a sense, it could go to negative infinity, right? Because n is a really small number. All right, let's take a look at this problem. We want to show that limit as x approaches 3 from the right of 1 over x minus 3 is equal to infinity. Right? We're going to use the definition of infinite limit to prove this problem. But before we do that, let's take a look at the graph of this problem. See what happened to the function 1 over x minus 3 around 3. Right? So here I have a function 1 over x minus 3, and around 3, as you can see, if you approach 3 from the right, let me take a screenshot. If you approach 3 from the right, like that, it looks like, you look it up, it looks like the function is go to positive infinity, right, without bound. So let's prove that using algebra or definition of the infinite limit. So let's so here we're gonna use, so the first sentence will be this one right here, right? So for each m that greater than 0, so for all m, for some arbitrary big positive value m, there exists that little funny e, backward e, mean there exists a delta positive such that if x minus 3, here c is 3, that's between, I don't need the absolute value, between 0 and delta, then the function f of x, which is 1 over x minus 3 here, is always bigger than m. Right? Again, m is some really big values. Right? The reason I don't need the absolute value here because oh, I'm sorry, we are taking the limit as x approaches 3 from the right. Okay, so we want the positive case of the absolute value. Right? So the first part is, I call it the scrap work. because we need to find the delta. What is delta first, right? So first, phi delta. In order to find delta, we're going to use this inequality right here. 1 over x minus 3 is greater than m. So if you want to take the reciprocal, then x minus 3 is less than 1 over m. And that's right here. That is our delta, right? That is our delta right there. Right? X minus 3 is less than delta or less than 1 over m. Now is a real proof. Let me separate this. Right. So now, given some big value m positive, then we let delta is equal 1 over m. And suppose x minus 3 is between 0 and delta. Then just take the reciprocal, right? So 1 over x minus 3 is greater than 1 over delta. But delta is equal 1 over m, so just plug it in, right? 1 over m, right? Which is m. Right? So we're done. Indeed, 1 over x minus 3 is greater than m.